But also I have a bit of time. 0 solves in contest. Oh. Alright. Okay, welcome back everyone. So, this problem is from, I think it's Exeter's middle school contest is what this stands for. I never figured out. But let me put the problem up. Nope. That button, this button, right? Cool. So, you're given an equilateral hexagon whose opposite sides are parallel. All the sides are length 3, and the area of the hexagon is 5. And I need to compute... What the heck is that? Okay, some product, whatever. Okay. But I mean, like... Okay, so if it's equilateral with opposite sides parallel, I really should be drawing like the center, right? So it's kind of these there's 6 vectors, each of them, and then the vectors corresponding to the sides come in various pairs. So probably I think the cleanest way I can represent this is okay, we'll call, well, here's A, B, C, D, E, F. And then each of these vectors is a vector of length 3. And they're all everything's symmetric around this origin. Is that the only condition? Like, I feel like if I just have if I pick any 3 vectors like this, this, this that are of equal length, that parameterizes everything completely, right? Because it's like you then E and F are the reflections. Let's give this the origin O or something. Okay. So maybe it's better if I rotate this picture, which I don't know if I'll be able to do that. Let's see how good my technology use is. Is there a rotate tool? Oh my god, there's really a rotate. Okay, sounds good. Nice. So, where'd my pen go? Pen. I'm gonna rewrite the labels so that they're like... I don't really think... So I think half this picture doesn't actually matter. Like, I just care about these 3 vectors, and then they do something. Oh yeah, here's EF. So in particular, I think I have 1 extra degree of freedom, like, right? Because I have, like, I'm picking like 2 angles, like the angle of B to C and the angle of C to D. That determines the entire hexagon uniquely, and there's only 1 condition, which is the area. So there's going to be 1 extra degree of freedom in this problem. I don't know if that's a big deal. I mean, we'll just live with it. Might not matter. But it means that the specific thing that's being asked for, which is AC times BD... Wait a minute. Okay, so first of all, also they're trolling me because AC is equal to DF, right? Like, it's just kind of whatever. Yeah, so I guess it's just I need to understand how the area condition is being interpreted. Which... So how do I get the area of the whole hexagon? I guess that's what I want to know. Yeah, by symmetry you only need the product of three of them. Because like AC is equal to DF or whatever. So I mean, okay, I'm just gonna try some. This is not very elegant, but I think it's supposed to work. Where I'm gonna label these as PQR, like so, and then I'm gonna label the angles as like alpha, beta, gamma. So the condition that each of these things is side length 3 is saying that 3 squared is equal to whatever you get with the law of cosines. Cos alpha, yada yada. Actually, this feels pretty bad. I think this is gonna turn out to be really ugly. So there's a relation between like cos alpha, cos beta, cos gamma, which is that alpha plus beta plus gamma is 180. So it's there's some condition, I never remember what it is. Also, yeah, this is actually going to be really annoying. Whereas AC squared, AC times DF, I guess, is equal to P squared plus R squared. And then it's like alpha plus beta, so it's actually minus 2PR cos plus 2PR cos gamma, or something like that. Oh, this is pretty bad. So this is gonna work, I think, but it's pretty icky. And then it's like sine. Oh god. Yeah, the areas you get from the signs, like PQ sine alpha is 10. PQ sine alpha plus QR sine beta plus RP sine gamma. So I think like this will eventually work if you force it. I just don't really want to. Because you know that there's going to be some like quote unquote algebra miracle because you're sort of promised that in advance from the fact that there's one extra degree of freedom. So let's see. Yeah, no, this is really bad. Oh, I don't want to transfer. 5 equals PQ. No, I think I mean 10. Because the area. Oh, I see. Sorry, you're right. I only counted off the hexagon. My bad. Okay, never mind. Let's not do this. I think this is too icky. But so if I don't want to do this, I need some different way to access the area, which you can. So I guess I can try the side thingies. Freaking. Okay, so there's like a billion equal angles in this problem, right? Actually, I think these 3 triangles are actually all congruent. Like if I call this one beta and this one gamma, this one's also gamma, beta, beta, this one's alpha, alpha. Yeah, okay, so there's actually just 3 congruent triangles. Okay, sure. It's just I don't actually see why AC times C times EA plays a role in that case. But, sorry, I lied. The triangles aren't congruent, they're just similar, and these all have side length 3. And this is all, yeah, everything's 3s. It's like, how do I get AC times CE? Yeah. So okay, the whole giant triangle, like the big green triangle, will also be similar to this. To each of the little triangles that's hanging off each of these edges. Doesn't say very much. Or I really don't want to set things up. Yeah, they're similar. The thing is, like, the side that's equal to 3 is different in each of them. What the heck? Okay, so if I cut out the shape and declare that the entire giant triangle, sorry, not cut out. We'll just do this. Oh, this is so annoying. We'll call this C. I want to get the symmetry right. B, A. Then you can, all of the other lengths all follow from a symmetry argument, right? So this is like 3b over a, for example. And then this one is 3b over c. So we get this like relation that b is equal to 3 plus 3b over a plus 3b over c, which just says like something. 1 equals 3 times 1 over a plus 1 over b plus 1 over c. And it's ditto for the other things. So yeah, okay, I guess that's that. That's all the information I can get out of ABC, actually. So it's just, there's something about like the specific thing that's being asked for, like AC times CE. that I'm not understanding. Oh, also I should compute the area. So so the yellow triangles, what are those? It's like okay. 3/8, right? So this thing times ABC times the area of ABC is the sum of the yellow things. And apparently if I add 5 to this, I'm supposed to get ABC itself. So this is the other, okay, I'm gonna hide the trick stuff because I'm not gonna use it, I think. Yeah, the trick is too annoying. We're not going that route. But if I use ABC as my 3 variables, I'm expecting to get 2 equations. So one of them says 1/a plus 1/b plus 1/c is equal to a third. The second one says that the area of ABC is equal to the given 5 minus 9 1/a squared plus 1/b squared. Okay, so that's what the given conditions become, if I haven't messed up. Yeah, the area condition doesn't actually seem to play super well. Well, okay, so the denominator kind of sucks, I guess, but 1/9 happens to be the square of 1/a minus 1/b. So it might be easier if I rewrite this as like 5 over... So, okay, so 1/a squared plus 1/b squared plus 1/c squared is equal to 1/9 plus 2 over AB plus 2 over BC plus 2 over CA, which feels a little better to work with. Because that's just equal to 5 ABC, CA plus B plus C. So I mean, this is what it is. It's not an amazing equation, but that's what we have. It's the real issue is I don't understand the answer extraction. Like, you can't solve for ABC because there's 3 equations or 3 unknowns and 2 variables. Yeah, I agree that it's the square of AC times CE times EA. However, I mean, I don't know what that quantity does. Yeah, like what is AC doing? Like AC is the one that doesn't seem to have any natural It suggests considering a different approach. I mean, I'm just parameterizing stuff right now. Like the problem I have is that I don't know what to do with AC times CE times EA. Maybe there's a circle. Why? What circle? Wouldn't it be cool if this was the solution? Like, that doesn't help me. Oh shit, sorry, I fucked up this equation, didn't I? Sorry, this equation is completely messed up. Yeah, I dropped like a factor of 9. I don't see it. Alright, you know what? I'm just gonna run it over. So, AC squared equals... well, not even AC squared. AC is equal to twice the 2 times 3 times the sine of 90 minus beta, like angle B. What? I don't see what it, like... How do you do trig? It's like, okay, it's opposite, right? So this is well, actually I don't... crap. Which way does it go? Okay, I put the 90 in the wrong place. Okay, wait. Sorry, I'm really bad at trig. That's the real problem. So it's... okay, this is the angle that's being split between. Yeah, okay. So it's like R over S minus B. Okay, cool. Where R is the in radius of the ABC triangle. And then similarly for the other ones. So the desired quantity is then equal to the square root of the answer is then equal to something like 2 cubed times 3 cubed times r cubed over s minus a, s minus b, s minus c, which will then equal 6 cubed times, so the bottom thing is the area. Yeah, the area is the annoying thing. So if I multiply top and bottom by s, r cubed s, so I get like r squared over the area. I think I get one copy of the area left. No, I should just clear the whole thing. Well, we'll just multiply both top and bottom. It's then enough to compute ACE. I mean, okay, but like... Area of ACE is 5/2. Wait, why is that true? Am I high? ABC the points. No, sorry. I really shouldn't use brackets ABC. I should say like let K be the area of the triangle with side lengths A, B, C. ABC squared on the bottom. Yes, thanks. Yeah, honestly, I should be using like X and Y instead of 3 and 5 or something, so that I can actually do the dimensional analysis. Okay, what are people talking about? I cannot keep up with this. You know what? I don't care about geometry. We're just gonna finish this. Okay, so I need to find k over s squared given like these two equations. K equals, yeah, 6 cubed times frac r over. Okay, and the original equations we have are something, I don't know, ABC. Yeah, I'm mostly worried that I like mistranslated something because that's the kind of thing I would do. Shit, yeah, I mistranslated something. Oh, frick. Oh no, it's not r over s minus a. So, okay, this is how I know no one's paying attention to anything I'm writing because, like, this sign thing is just, it's not a sign, right? It's, or it is sign, but you don't get r over s minus a. You get something that's a lot crappier. It's like, oh, Jesus Christ, that's so annoying. Yeah, it's not r over s. Okay, never mind. All this stuff is wrong. Hello, there's a math problem. I'm currently doing stupid head things on it, and everyone's yelling at me because apparently there's a really smart solution and I don't see it. That's basically the summary so far. I'm just gonna let x equals 3 for... so I can actually do dimensional analysis properly. Oh jeez, it's like 2x cos beta over 2. I just... that's probably why you need it squared. So like... it's like ax cubed. And then square of cosine... How does this work? I never remember. Ah, if it's square of cosine, it's going to get really ugly. Okay, fine. We're not gonna. Yeah, I don't want to do a square of cosine. I thought it was like little r, but it's not, which is why it wasn't working out. Fine. Ah, okay, I see. I'll deal with that later. This is what you're trying to get me to do, right? Yeah, I don't know. I guess it's fine. Feels kind of scuffed to me. But like, okay, fine. Yeah, I really wanted the little ABC thing to work, but I got the half angle wrong, so it's gonna be something a lot worse. Anyways, for the people who are catching up, basically the premise is that you can characterize all hexagons that are equilateral with opposite sides parallel as you take the circumcenter of a triangle and reflect it over the three sides. Those are the other vertices. So this B is AO plus CO, for example, and so on. So what that means is, in particular, ACE, well, triangle ACE has circumradius 3, and also its area is 5 halves, because it'll always be half the hexagon, because like this one is the same as this one, and similarly. Okay, and then finally what you do is you use the fact that AC times CE times EA over 4 times the circumradius, which is 3, happens to be a formula for the area. So 12, 6, 30 is equal to 30, so consequently, if I didn't screw up a factor of 2 or somewhere, it should be 900, I think. I just completely blocked now. Well, yeah, like so. Put it in the trig unit? No. I really wanted to bash it because I was trying to get a solution that just was like, because I think the thing about this is that it's one of those things where you have more variables than equations. Like the hexagon has 3 degrees of freedom, and then there's 2 constraints, side length 3, area 5. So there's like a one-dimensional family of things that satisfy it. So it's kind of like, if you do some set of calculation setup, it should like do something with like some, there should be like one, yeah, extra degree free. Yeah, knowing that it's a middle school contest definitely helps. Like, you know, the trig is not the intended route. Yeah, I was, okay, anyways, that's fine. At least we got it. Okay, cool. Yeah, probably it feels like you add this to, we'll add it to Amy Geo, that's fine. Also, T14 is, do you have a 15 problem test and there's a problem that's nominally harder than this? Yeah, this is a middle school contest, which is why, I don't know. I know the solution is going to look something like this, but I just want to see if I can brute force it, but no such luck. It's unoriginal? Well, yeah. I mean, I think the point is that you're relying on the fact that an equilateral hexagon with opposite sides parallel has a different description. Which I was trying to avoid, but I eventually was just like, ah, screw it, we'll just do it. I need a diagram. The MCC. Oh, 15 is unoriginal. I feel like this should be known too, though. Like, it's... let's use warm colors for this, and then Why did I not compile? There we go. That's a little too strong. Okay. So by vector calculation, points A plus C minus B plus A minus coincide at point O, which is the circumcenter of triangle ACE. GEO equals oh, I forgot to share the screen. Freaking. Yeah. Ta-da! Particular, we have op name area ACE equals 5/2. There are people that are younger than your chat message. Oh no. Whatever will we do? 4 times 3 and hence okay, meanwhile now df equals AC, C BT FB equals E, BT equals CA. Have you played Technique? Yes. At some point. Long time ago. Yeah, I imagine I would be better at it than like the average math contest person, but not super fast. Because I'm really used to using like my own macros and things like this for typing up stuff. Equilateral. Compute. I don't know the URL for this. No, guys, the problem is I'm used to editing in Vim. Like, I don't spend a lot of time like typing into just like a text box, a dumb text box with no editing capability. What text do I? I can put the link tag, I guess. What is the vector calculation AC? Here. Like basically the point is that in this problem, A, B, B, C, C, D, D, E, E, F, F, A are these vectors that have the same norm. Like they're vectors of length 3. So if you define B as like maybe I should write that out actually. I don't think I can comment on whether I have problems on future contests. That seems to be not a sensible discussion. But like you can, one thing you can do is you can define O as like you take A and then shift it by the vector C minus B equivalent to the vector E minus F, and then that will coincide with, I don't know. It's like A, B, B, C, C, D, D, E, F, F, A are these vectors of, they're unit vectors with something. How do I describe it? Maybe I should just say construct parallelogram. Okay, yeah, let me not use vectors actually. This is construct parallelogram. I think it's easier to see it this way. COED, then ABCO is also a parallelogram because AB equals yeah. And similarly, AFEO is a parallelogram. So the point O is this, thus the circumcenter of triangle ACE, since, or because. Yeah. Okay. Yeah, okay, yeah, I should have just done this earlier. I don't know. I really wanted the 8, like, side length thing to work, because, I don't know, symmetric things, but it's fine. Yeah, good job middle schoolers who got this, which apparently is the empty set. Yeah. Alright. Alright, cool. Thanks for tuning in for those of you watching on YouTube. See you next time.